Hey guys, this is Mitch with Fine Point CGI, and today we're going to talk about 3D navigation with Godot 3.5. So we're going to go through the process of setting up our scene. We're going to go through all of the different options. I mean, there are so many options with the 3D navigation system that's going to be the majority of our runtime for this tutorial. We're also going to talk about how to do dynamic object avoidance, and we are going to talk about how to make an object follow you at different speeds using the navigation system. And finally, we're going to tie all this together and build ourselves a small horse that kind of just follows you around, and you can jump on top of it and ride it around and things like that. So that's what I have in store for you guys today. So let's go ahead and get started. All right, so I have here a very basic 3D scene with a couple of objects that have collision, a floor object, a camera, and a small player. And if you are following along at home, a link in the description below to the project is right there for you. And if I hit play, you can see kind of what we have. So we have a little guy that can run around, can collide with things, and that's pretty much all it does. Now, I already have a horse object right here that I can just drag into the scene, and you'll see it's basically just a big old horse object here, and it doesn't have any animation or anything like that. It's actually a model that I pulled from Sketchfab that I'm using for this. Now, if I drag this guy over here, we're going to have him navigate around and up to the player, and we'll allow the player to mount the horse as well and run around. Now, first, we're going to need to go through how all the navigation is going to work. So let's go through that. So first, we'll right-click our spatial node, add any child node, and type in navigation. And you'll see that we have what's called a navigation mesh instance and a navigation node. And much like my 2D section, if you haven't seen that, navigation is going away. The actual navigation node is no longer really supported. It's getting removed with probably 3.6 or sometime in the future. So you should just use the navigation mesh instance. So let's double click and add that. And then let's drag our CSG mesh, which is our world, into our navigation mesh instance, just like that. Now, if we click on our navigation mesh instance and we come over to our nav mesh here, and we click new navigation mesh and we click on that, unlike 2D, we have a bunch of options here, which is really cool because it means that we can really play with what we can do with this. So first, I'll draw your attention up here because it's a little easier to start with this. If we click bake nav mesh, you'll see, bam, we have ourselves a nav mesh, which is pretty cool. And the default settings that Godot has is actually really good and really useful for us. Most of the time, I don't even need to come into these things and edit it. But in case you need to edit it, let's run through all the options and we'll go from there. So first you have sampling, okay? And sampling has only one option, which is the partition type. And the partition type is basically the algorithm that's used to create your navigation mesh. So a lot of times watershed's great, but if you look at like monotone and you run that, you'll see that it kind of cleaned up some of these edges, right? So you can see watershed versus monotone. It's a slight difference in this area, but it's enough that it can make a big difference with your navigation. Layers, on the other hand, uses layers to build up your nav mesh, okay? So think of it like this. Watershed basically projects array from top down and creates your nav mesh. Monotone, to be honest with you, I'm not sure how it works, and layers builds it with layers, more or less. Usually I just click through them and see which one does the best, and then I go from there. In my case, monotone is usually my go-to, so I'm going to use that one. Geometry is super important because it's all about the geometry that's in your nav mesh. So you can see they have parsed geometry type, so you can see where is it going to get its geometry from, either mesh instances, static colliders, or both. Now, what this means is if we go to static colliders and we bake, you'll see we have nothing. But if we right click, add in a child node, and add in a static body here, and then we right click, add in another child node, and add in a collision Oh, that's not what I wanted. Right click, add in a child node, add in a collision shape here. And we set that to something like a small box shape. And we just kind of pull this over here. If I come back to my navigation mesh instance and I bake, you will see that that object, that collision has navigation, but nothing else does. And that's because it only works on static bodies that have a collider. Okay. Now, if we change this to both and we click bake, you will see that we get collision on our collider and on our actual mesh itself as well. Now, the default mesh instances works, but you'll see that it doesn't work with objects that don't have a mesh. So that's something to keep in mind. A lot of times when you're doing 3D navigation, you might not want the bad guy to be able to pass a specific area. So you could create a collider there that says, hey, you can't walk by this, basically, and then use the both for the parse geometry type, and it will allow that nav mesh to never let anyone go through it. Now, coming over here, source geometry mode, you have nav mesh children, group with children, and group explicit. And basically, this is saying, where are we going to get our geometry? In this case, it's all of the children of my nav mesh, but we could do a group with our children, which if we actually say, take this guy out here like this, and then we add it to a group called nav mesh. I believe that's the name of the group it's expecting. Let me take a look. Nav mesh. Yep, that's the name. So we will add it to that group. Then if we come in here and we click bake, you will see that this object, this one, has collision and has a nav mesh, but these two guys don't. And that's because they're not part of the nav mesh group, if that makes sense. You also have underneath here group explicit, which is basically saying, I only want objects with that group, basically. Now, in my case, I'm going to keep it with nav mesh children because to me that just makes sense and it works. So we'll just keep that. Now, underneath cells, we have the size and height. So if we adjust the size of our cells to be very large, you will notice that we can't bake at all. But if I bring it down just a tiny bit and I bake, we still don't have anything. Let me bring it a little bit further down. And you'll see kind of what it's doing. So it's increasing the size of each cell for nav mesh. So the smaller you have it, the more detailed your nav mesh, but the more resource intensive it is when it needs to calculate your navigation. So you want to be able to balance it for your size. 0.25 is a good number, but sometimes you might want to make it a little bit bigger if you have a bigger nav mesh. You might want to make it bigger because it will give you a little bit wider berth on your objects, and it will be a little bit easier to calculate. Height affects how high off the ground your nav mesh is. So if I set this to something like 3 and I bake it, you'll see it's way up here. If I set it to 0.1 and I bake it, you'll see it's way down here, almost touching the ground. Now, the question that you might be asking is, well, why wouldn't I just set it to 0.1? And sometimes if you have objects that are small and you don't want it to be brought into the colliding system of a nav mesh, you would just increase your height so that way it doesn't quite need to deal with that little bit of extra information. Next up is agents, and agents is basically your agent's information. And I know that that doesn't really give you much words, but basically when you have something on your nav mesh, it's called an agent. It's a thing that exists in your nav mesh. And these are its properties for all nav meshes. So its height, so how tall your agent is. So if it needs to duck underneath something, if the height is too high, it won't be able to. So the nav mesh will work around that object. Radius is how wide an agent is. So if you bring that radius up, you'll see how it affects the radius of your agent. So like this guy is an agent, right? He exists. And you can see how the radius affected it. So you can kind of make it smaller, and you could actually really crush that down, something like that. And you could really get nice tight geometry here to make a very detailed map. But the closer it gets to actual collision geometry, the more likely you are to have your object collide with the actual object. and that could be a problem. So a lot of times people put these objects and their nav mesh agents on their own collision layer so that they don't collide on things. But that's just something to keep in mind. Max climb is how high a nav mesh agent can climb. So if you drag this up to a really high number, you can kind of see what it does. It basically allows you to determine how high something is to be traversable. And this is in units. So in this case, it's 0.25 of a unit. So if I put this on Z axes, I guess they really don't show it here, but it would be nice if they showed like a grid so I could show you. But basically like 0.25 is like right here ish of a unit. So this object here would be considered unclimbable by my horse guy here. So that's something to keep in mind. And max slope is the maximum slope at which we're going to be able to have a nav mesh. So if I grab something like this guy here, and I go with local transform and I do something like this and I bake my nav mesh, you'll see that that's considered non-traversable. But if I take it and I find the object and I do a smaller, gradation here like that, and I bake it, you'll see that it is traversable. So that's what that affects. And if I bring this down, you'll see when I bake it, it's no longer traversable. That's what this is for, is it's just to say, yes, something at a 45-degree angle or an 80-degree angle is traversable, more or less. Now I'm going to undo all of that and rebake my nav mesh. Next is regions, and regions is how big of an object is before it gets called out of the nav mesh. So if an object is smaller than 2 units, so if it's smaller than 2 of these little guys, then it's not. Then it's going to get called out of the instance. It's not going to be counted as a traversable navigation mesh. And merge size is how big an object can be before it becomes its own nav mesh. Basically, it's for memory. You'll probably never change these, but they are useful to have. Edges determine the edge length of your nav mesh before it breaks it up into a separate vertex. And really, again, this is stuff that you're probably never going to touch, but basically the max length means that this is 12 units before it says, okay, I need to create another vertex to kind of help make it so that my nav mesh isn't as big. Max error is the amount of error a object or a mesh can have before it calls out that nav mesh and tries again. Polygons is pretty simple. It's basically the number of verts per poly. So if you were to set this down to something like 3 and bake your nav mesh, you really won't see too big of a difference, but basically it's changing how it creates this. So think of it kind of like this. If this is 6, then that means that it could take 1, 2, 3, 4, 5, 6 and make this into one nav mesh or one polygon. If you had it set to 3, it could just take 1, 2, and 3 and make that into a single polygon. So that's how it knows how many verts per poly. And again, this isn't something you're ever going to really use, but it's useful if you're having memory problems or if you're trying to get your nav mesh to flow a specific way. Next up is details, and details is when it does its detail pass, it actually does a sample distance and a sample max error. Sample distance is how far is it going to sample to kind of make its detail map, and sample max error is how big of an error is it going to be before it calls it out. And again, you're not really going to use this, so I wouldn't really worry about it, but it's nice to know that it exists. Filters allow you to filter out objects. So for instance, you can filter out low-hanging objects or obstacles, which means if an obstacle is low hanging and it's close to the nav mesh, then it will filter it out and say that it doesn't have collision and it just lets you walk through it. Ledge spans is if a ledge spans over top of a collision mesh, if it's going to call that out or not when it's doing its navigation creation. And walkable low height will actually call out the navigation mesh piece if it's below your agent's walkable height. So think of it kind of like this. If you had a span of an object right here, right, that is lower than what your agent's walkable height is, it will actually say you cannot walk through this area. That's what that checkbox does. Baking AAB is something, again, you'll never really use, but basically you can specify a size of a box basically and say, I cannot bake outside of this box. And that's useful if you're doing something like baking your nav mesh at runtime, or if you're not wanting to bake the entirety of a scene, you only want to bake a small section of it, you could use baking AAB to actually facilitate that. And baking AAB offset is just the offset of that AAB. So a pretty good use case is if you had a segment of a environment that's 500 meters by 500 meters, so it's a really large place. Instead of baking it all at once, you could say, okay, let's bake a small segment that the user's in on level load, and then when they walk into a specific section, okay, now bake the next section by using the offset, if that makes sense. Generally speaking, you're not going to use it, but it's nice to see that it is actually there. Outside of that, we have enabled, which I've already gone through with my 2D. It's if it's enabled or not. Navigation layers, which is if an object is on separate layers, it's not going to be taken into account when it is being navigated on. So for instance, if our mesh agent, this little horse guy, is on 2 and this is on 1, then the mesh agent is not going to be able to use this navigation mesh. So this is nice if you had a navigation mesh for the player and you had a navigation mesh for the enemy and you wanted them not to be able to use each other's navigation meshes. Enter cost and travel cost is how much does it cost to enter into this navigation mesh and how much does it cost to travel through this navigation mesh. So for instance, if you wanted your horse to only go around this navigation mesh, you could put the enter cost to be really high and say, yeah, coming through here is going to cost a lot of points. The only time that you want to do that is if you specifically need to come in here for a specific reason. And same thing with travel costs. If you want to come through here, it's going to cost you a lot of points. And if you set this to a high value, then the horse would go around this nav mesh because it's a higher cost than the meshes around it, if that makes sense. So now that we've gone through all of the options, let's get this horse to follow our little player. So we'll go up to our horse, we'll right click our horse, we're going to attach a script, and we're just going to call it horse.gd. I think that will be fine. And we will click create. So much like before, we need to make it so that we can navigate our object, right? Our horse. So if we go into our horse scene and we take a look at that real quick, you can see here's our horse. He's beautiful. And we can basically put in a navigation mesh, much like before. So first we'll right click, add in a child node and add in a nav mesh nav agent here. We'll put that in, and we also have to give them collision, so we'll add in a collision shape, and we'll need to change our type of our horse to a kinematic body. But first I'll just grab a box shape, put that in, right click, change type, and change it to kinematic body, just like that, and that'll basically clear up all of that. And our collision shape needs to be a box shape, but I feel like my box has disappeared. I've been running into some small issues with how Godot handles instancing in meshes, and I'm curious if other people have ran into that. So I guess let me know if you guys actually have ran into this with 3.5, because I've been running into this a lot with 3.5. But what I'm going to do is I'm going to drag this up and make sure it matches up with my screen size or with my object size, just like that. And what I'm going to do is I'm going to actually put my horse script on here. And now that we have our collision, we need to put our timer node in like we did last time. So we'll just right click our horse, add in a child node, add in a timer, just like that. And we need to attach our timer's signal to our horse. So we need to put our horse.gd onto our object, grab our timer, go to our signals, on timeout, let's just connect it to our horse. That way we have that. And we should be pretty much set up for our horse to work. Now, we're not going to be able to ride our horse, but we can cover that later if we want to. But we'll at least have an object that follows our user around, right? So first, let's hook up our agent velocity and our agent like we did last time. So we'll say var nav agent, and we'll make the type navigation agent, just like that. And we'll say nav agent is equal to $navigation agent, just like that. And then we need to hook up our signal. So we'll say nav agent dot connect. And again, if you're not using object avoidance, then you don't need to use this necessarily. But in my case, since I'm going to be demoing it, we will. So you'll put in your velocity computed, and then you'll target yourself. And then you'll say underscore on underscore velocity underscore computed. To me, that's just a standard I like to keep. And then we'll put it right here. Just like that. All right, so now we need to make it so our object will follow us. And much like before, we can just do it through our physics process. So we'll say func physics process delta, and we'll need to check if our nav agent is completed. Just like that, and if so, we can just return. If not, then we need to move our object, right? So much like we did before, we'll just say var target position is equal to nav agent dot get next location. And then we need to, of course, get our general direction that we are going. So we'll say var direction is equal to our own global transform dot origin dot direction to, and from here we need to set some kind of target position. Okay, and we actually have a target position right here, so we'll set it to our target position just like that. And then we can get our speed and move our player. So we'll say var velocity is equal to direction multiplied by our agent dot max speed, and that will grab our agent's maximum speed and multiply it, much like we did with our 2D side of this. And now finally, we can basically just fire off our move and slide. Now, if you type move and slide, you'll see that it doesn't come up, right? And the reason why is because that's my fault. This extends spatial. It should be extending kinematic body, just like that. And then move and slide should work. So move and slide, just like that. We have to pass in our velocity and our up vector. So we'll say vector3.up. And that basically just tells Godot which way's up. And that's useful for like, am I colliding on the floor and things like that. So now we can hit Control S, and now we need to actually tell our horse where our player is. And we don't really have a direct way to pull our player over here. So what we'll do is we'll just go into our player right here. We'll go over to a group and we'll just add them to the player group, just like that. And then we can just come back to our horse, click on our little script icon, and just say nav agent dot set target location. And then we have to get our player. So since we have our get tree dot get nodes in group, and then we can grab our player node and we can pull back the first reference of that node list that's going to come back. And then we can just say dot global underscore transform dot origin. And hopefully that will work for what we're trying to do. Now, if we click on our timer and we go to our inspector here, we can change our process mode to physics, and then we can come in here and do auto start. And let's just drag our wait time down to something small, like 0.14. And if we hit play, hopefully everything will work. So if we click on our spatial scene here and we hit play, And you can see he basically starts attempting to path forward to us, but he gets kind of stuck on that object there. See that? And now he's attempting to path to us, but he keeps getting stuck. And the reason why is A, he's not rotating, which isn't helping, right? You need him to rotate. And B, he's struggling with some of the collision of some of these objects. And that's one of the reasons why I said you might want to shut off or move your horse's collision onto a separate layer like this, and then maybe put the player on his own collision layer like 3 and 1, and make sure that the horse is also on 3 and 1. That way everybody can kind of, he still collides with the player but doesn't collide with the world as much, and that can help a little bit with the navigation problems that you're running into. See that? So that's something to keep in mind, because sometimes the collision system likes to get nice and close to you, and it makes it, can make it a little on the difficult side to get around things. But that's also where you can come into your navigation mesh instance and increase the buffer of your nav mesh. So, you can come in here and actually adjust this cell size and maybe make it a little bit bigger and make it so that it doesn't collide with these objects if you want to do it that way. Both ways technically work, but it helps with keeping him from getting stuck on objects, if that makes sense. So that's pretty great. At least we have it running and we have it working. So now the question is, how can we make it so that it does real-time object, collision detection? Well, that's pretty simple. We basically just treat it like we treated everything else. You come in here and you right-click on your spatial node, you add in a child node. We add in a kinematic body like normal. We right-click it, add in a child node, and add in a mesh, and we're going to add a CSG mesh, and we'll make that into a cube. So hopefully that will work, which it didn't. And like I said, I'm still having problems with it not instancing my cube. I'm not sure why. I can instance a cylinder, so I guess I'll do a cylinder. So what we'll do is we'll rotate this. We'll pull it up, something like that. We will right-click our kinematic body, add in a child node, add in a collision shape. We're going to make that into a capsule shape. And then let's just rotate that 90 degrees and we'll drag it up so it matches the size of our object here. And then we'll move our kinematic body to somewhere like this. And what we'll do is we'll do what we did last time. We'll right click it, add in a child node, we'll type nav, and we'll do a navigation obstacle. And we'll click create, and then we can right click our kinematic body, add in a child node, add in an animation player, and basically do what we did with our 2D, providing you watch the 2D. If you didn't watch the 2D, basically we added a animation and we just said move, and then we basically animated our kinematic body. So you just come in here, click on this guy, go to transform, put in a breakpoint right there, maybe extend this to about 3 so it doesn't go super fast. Make it about 1.5, make it go across, click, and then go here and basically grab that and duplicate it just like that. And now you've got a little moving guy. We're going to click our repeat so that way the animation will repeat just like this. Simple enough. And then we're going to go into our kinematic body, make sure that our collision layer is on the second layer so it collides with the horse and with the actual ground mesh itself. If you click on your navigation obstacle, estimate radius, which will use our kinematics collision shapes to determine its size. Simple enough, right? So now all we have to do is change our horse. So if we go to our horse and we click on our script icon, we need to use our velocity computed instead of our move and slide. So if we come in here, we can actually just grab our move and slide, cut it, come down here to our velocity computed, and we'll need to pass in our velocity just like that. And instead of doing our move and slide right here, we basically just tell the agent to say, hey, we need our velocity to be a specific size. So we'll say nav agent dot set velocity, and we'll just pass in our velocity. Just like that. And that'll allow us to do our velocity computed. Now, this won't work right offhand. And the reason why is because we need to go to our horse and we need to actually go into our horse scene here. Click on our nav mesh agent and you'll see that we have our avoidance. So we need to turn that on. Once we have our avoidance enabled, then we should be able to hit play and it should, in theory, work. So we'll hit play. And it didn't play our animation, so that's always a good sign because I forgot to add it. So we'll tell our kinematic body, we'll attach a script, call it kinematic body, that's fine, $ animation dot play, and then we'll play our move animation, and that should work in theory as long as everything is set up correctly. Let's try it. Now, if we hit play, you will see that he's going to attempt to go after that object there, and it'll try to avoid getting hit by that object. Now, if it does, it goes through the wall. So that's kind of a limitation of doing the collision adjustment that I did. So maybe we should have it collide on those walls and then maybe change our collision shape from a box to maybe something like a cylinder. Might work better. So we could try a capsule shape and see if that helps. It might not. So we'll see. So we'll try that and see if maybe that will work better. I mean, I'm okay with the head of the horse not having any collision. I don't think that really matters. But let's see if that does it any better, because the colliding off of not being able to collide off that layer, I don't think is going to work for us because our nav agent is getting knocked off. But we're going to need to play around with it. But you can see that he attempts to avoid this object, which is awesome. So now that we have that, basically you have an understanding of how the nav agent stuff all works. You can see the reason why we're having collision issues is because this is so close that the object is actually colliding with it. So, we can fix that by just basically making this slightly bigger, something like maybe 0.6 or maybe 2. That's way too big. Maybe something like 1, something like that might work a little bit better. If we hit play, we'll see how that goes. But that's basically how we do the navigation mesh system. Now, I know what you're wondering. Okay, so what about moving platforms? Can we have multiple mesh instances? How do we handle that kind of stuff? And yes, you can have multiple mesh instances. And yes, you can actually have moving platforms and things like that with navigation. As a matter of fact, if we duplicate our navigation mesh instance, and then we just drag it back, something like that, and then we click our click this navigation mesh instance, and we add in an animation to have it move back and forth. So let's do that. So we will add in a child node, add in an animation player, select our nav mesh instance, go to our transform, and we will add in an animation. We'll call it move for sake of simplicity so that I can reuse my previous code. And we'll make this, I don't know, a 4-second animation, let's say, something like that. We can click and create a translation, go to 2, drag this guy in, something like that, so they're connected. And then click on translation and then go back to our previous section. So you can see that it goes back and forth. We can make that repeat. Actually, I think what we'll do is we'll drag this back like this and then come here and then just control duplicate that right here. So that way it stays there for a second. That should give our animation a little bit more additional time. And maybe, honestly, maybe we should make this a longer animation as well. Let's just go with 8 seconds. So that way we have a little bit more time, because this is basically future Mitch after I started recording this. This didn't fully work out, so let's make this just a little bit bigger of a timeline so the animation system has time to learn. And then what we can do is we can come up to our navigation mesh instance. We need to play that animation. So we can right click on our navigation mesh. We can attach a script, and we'll attach our navigation mesh instance to, just like that. And then what we can do is under here, we'll just hit $ animation player dot play, and then we'll play a move just like that. And that should play our little move animation. And if we hit play and we head down this way, you will see that he follows me through the navigation mesh. Now, if I come back like this, you'll see that he can't follow me until the navigation mesh connects. So if you go like that, you can see he actually gets stuck on that navigation mesh until they connect, and then he can follow me once again. So that's how we can handle navigation meshes that are multiple navigation meshes. So now that we've talked about sliding meshes and things like that, can we rebake our nav mesh? And when do we need to rebake our nav mesh? And yes, we can. And it's actually really easy. The only time that you really ever need to rebake your nav mesh is if you're instancing your a mesh that needs to be rebaked into the nav mesh system. So for instance, if you were to have a puzzle where you hit a button and then suddenly it extends a bridge or something like that, then it would need to rebake that nav mesh so that your enemies know that that area is now accessible. So how can we do that? So what we have to do is we have to go in and rebake our mesh when something gets instanced. So if we come out to our 3D scene here, and we head over here, you can see that we have a 3D scene right here. This is our object right here. We can just spawn something right here, let's say, okay? So what we'll do is we'll right click, add in a child node, add in a spatial node, just like that. Then we're gonna right click it, add in a child node, and let's add in a mesh CSG mesh, and let's set that to a cube mesh, providing that it wishes to spawn, which it did not. So let me try doing it a plane mesh, maybe. Does that spawn? Yeah, for some reason, my CSG meshes keep crashing on me, so I'm going to go and delete this. I'm going to right click, add in a child node. Let's add in a mesh instance instead. And I'm going to set that to a cube mesh, just like that. I'm going to scale it up something like this. And then I'm just going to move it over here so that way it exists over here. We'll pull it back just a tiny bit so it kind of clips in a little bit, so that way our navigation mesh, when it rebakes, will be able to recognize it. Now, what we have to do is we have to spawn it underneath our navigation mesh and then rebake that mesh for it to know what it is, right? So first we'll say, we'll call this spawnable object, and then we will right click and save it as a scene, and we will just save it as spawnable. That will be fine. And we will delete this object. So then what we'll do is we'll click on our navigation mesh instance. We're going to right click it, attach a script, and we'll just call it navigation mesh instance spawn. And I think that will be fine. And what we'll do is we'll use a timer to wait for 5 seconds, and then it will spawn our navigation, our new navigation mesh. So we'll right click our navigation mesh instance, add in a child node, add in a timer. And for some reason it did it like that. So we'll just drag this guy up and into our navigation mesh. We'll click on our timer. We will say auto start is on. We're going to set this to about 5 seconds. We'll change it to physics time because you always want it to be on physics if you can, especially since everything else is timed with physics. It just makes sense to keep it with physics. And then we'll go up to our node. We will click on signals. We'll click on timeout, and then we will connect that to our navigation mesh instance. And we will go ahead and click connect. And now we have a signal so that when our timer is completed, when this timer finishes, it will fire this little bit of code. So what we'll do is we will make this one shot as well, because I forgot about that. And what we'll do is we will make it spawn an object. So we'll scroll up to the top, we'll type export var, and we will export out
our spawnable object just like that. And actually, I should probably capitalize it since it's an exported object. And we'll make that type packed scene just like that. And then we can scroll down here and say spawnable object.instance, and we can instance that object. Now we're going to need to make that instanced object into some kind of variable. So we'll say spawned object is equal to our spawnable object.instance. And then we need to add it as a child to something. So we'll just say add child, and we will add our spawned object as our child, okay? And what that's going to do is it's going to make our navigation mesh have the spawnable object, which in this case will be this spawnable object right here. It will be that object that it spawns, if that makes sense. So now what we can do is we can select our navigation mesh and drag it up here and put it into our spawnable object, okay? And if you hit play and you run up here like this, you'll see after 5 seconds it's going to spawn that object. But our navigation mesh didn't rebake. Now, why didn't it rebake? Well, the reason why is because you need to tell it to rebake it. So you can get a reference to your navigation mesh here. So this object, in this case, it's this object. And you can type bake navigation mesh. And if you do that, what it will do is it will bake your navigation mesh once that timer runs. So if we do this, and then it spawns, you can see he can now walk on this object. So that's basically how you rebake a navigation mesh. Awesome. So now that we have that, at this point, the 3D side is basically done. If you needed a basic 3D tutorial on how to move your object around, that's pretty much the gist of how everything works for the 3D side of things. But one of the viewers suggested I make this horse into an actual horse. Make it so that that horse can do multiple different speeds and things like that. So I'm going to cover that real quick, and then we'll get to the exit, and then we will get out of here. So what do we need to do to make this into a actual horse-like object? How can we move this object faster if we are farther away? Well, all we have to do is come in here and change this nav agent max speed. If you change this nav agent max speed to something, then it will make it so that you can move faster on your nav mesh. So if we come in here and just say, hey, var distance is equal to global transform.origin.distance to, and then we could basically just do our target position just like that. Then we can basically just make it go faster. If distance is greater than 20, then we can set our agent max speed, right? Our nav agent. So we'll say nav agent.max speed is equal to something like, if I remember correctly, our nav agent max speed is, let's see, if we click on it, right now it's 10. So let's say, all right, if you're farther than 20 meters away or 20 blocks away, we will make it equal to 20. So you're galloping, you're moving fast, right? You want the horse to actually move really quick. Then we could say else if distance is greater than 10, then nav agent dot max speed is equal to 10. And then finally, if it's any closer than 10 meters, then we're going to make it so it walks, so that it moves nice and slow. So nav agent dot max speed, we'll make that something like, I don't know, 5 or 3, right? And then everything else in our code should just work. So now if we hit play, you will see he's moving nice and slow. Then he gets closer to us and he slows down even more. Now we might be able to make this a little bit more apparent by just saying, if it's greater than 3, then go that fast. If it's greater than 2, then go this fast. And if it's greater than the, if it's less than that, then let's just go to our regular max speed. So let's see how that goes and see if that's better. So you see how he sped up, and then he slowed right down. And actually, I think I might have found a bug. So I have target position here. And actually, we don't want to do it based off target position because that's the next point in our path. Instead, we'd want to do our player. So I think actually what we want to do is we want to just grab this information here, drag it up here, and see if that fixes our problem. So let's see what happens. Yeah, I think that's closer to what we're trying to do. Because if I print, let's print our distance. Just like that. And let's see what that does. So we get down to 3, we get down to 2. But by the time he slows down, we're already past our 2 section. So really, this should be something like 10. And this should probably be something like 4, I think. And let's see what that does. So if we refresh our scene. Oh, it's really hard to see because he's going so fast. So let's set this to something like 5, 3, and 1. And let's see if that can show it off a bit better. So you see how he's moving quick, he's moving quick, he's moving quick. And then he slows right down as he gets close to me. And then he gets to me and he slows right down. So that's exactly what we wanted. So that's basically how we can make a very basic, speeding up as we walk away, slowing down as we get closer kind of system. So awesome. Now that that works, let's talk about how we can make it so we can actually ride our little horse. I think that would be a lot of fun. And I know that this is way beyond navigation, but I figured that this would be a fun little add-on that we could take a look at. So let's go to our horse and let's add in the ability to ride this little guy. So let's right-click our horse. Let's add in a child node. Let's add in a spatial node just like that. And let's drag it up to the top where his little, seating position would be. And then let's duplicate that and let's kind of drag it down on the floor next to him. Something like that. Simple enough. Now, if we come up here and put seat position and have standing position just like that, then we can basically just have it so we can, register if our, so now all we have to do is just raycast, determine it if it's our horse, and then if it is, basically put us in the seating position, and if not, then put us in the standing position, right? So let's come over to our spatial scene here. Let's go to our player and let's get a reference to our horse. So we will say export var horse. And we're going to make that a node path. And what we'll do is we will also say whether or not we're riding a horse. So we'll say var riding horse. And we will make that a Boolean type. Just like that. And what we'll do is we'll come down here and we'll just say if input dot is action just pressed, and we'll just say UI accept, which is the enter key. I know it's not exactly ideal, but that's fine. It'll work for what we're trying to do. And what we'll do is we'll raycast to our horse and see if our horse is next to us, more or less. So we'll say var space state is equal to get world dot direct space state, and then we're going to do our raycast. So we'll say var result, and we'll make that a type dictionary equals space state dot intersect ray, and then we need to choose where we want to raycast from. And since our player technically is down here, this isn't going to work for us. So we need to actually get something to raycast from. So I'm going to right click our player, add in a child node. Let's add in a spatial node, and let's just call this raycast point. And I'm just going to drag this guy up here, and that should work. And I know that this isn't quite the best way to go about it, but what I'm going to do is I'm just going to raycast from that point. So $raycast point dot global translation. And then I'm just going to raycast in front of me. Okay. And I know that that's not exactly ideal, but we'll use it because it's going to make things, I mean, honestly, it's just a little bit easier. So we'll say vector 3, 0, 0, 5, and we'll just go with 5 units on the Z axis, which means it should fire off in this direction 5 units. So as long as we get behind the horse, it'll hit the horse. And like I said, technically speaking, you'd want to rotate the character around and raycast based off of the direction that you're facing. But for the sake of the tutorial, I don't think it's necessary. So we'll just do that. And then we'll say comma self like that. And then we can just print our result. And if we hit play, we move back like this and get right in front of our horse, or I guess in this case behind our horse, and we hit space, you'll see that we hit our horse. And if I stop this and scroll up, you can see we hit our horse, which is good. And we might want to change it because it'd be kind of weird to jump on a horse from behind. So let's grab it from the, let's say 0, -5. And I think that will probably be better because it's going to be -x. So it'll be on this side. And we'll just call it a day on that. And then what we'll do is we will check for our horse. So we'll say if result.size is greater than 0, then we can go ahead and actually check to see if it's our horse. So if result.collider.name is equal to horse, then we'll go ahead and allow us to jump onto the horse, right? So to do that, we need to first disable our collision shape, because if we collide with the horse, it's going to just completely teleport us somewhere randomly and try to get us out of that blocking volume. So I'm going to shut off my collision shape, and then I am going to say that I am riding my horse, just like that. Now, if I'm riding my horse, what we have, if you're riding your horse, you don't want to use these move and slides or anything like that, this input mapping, because depending on the horse you're on, it could be slower, it could be faster based off of whichever horse you're on, right? So I'm going to allow the horse to handle all the movement code. So if we're on a horse, then I don't want to do any of this. So if not ride horse, then don't do any of this. So that way, if we're not riding a horse, we can run around. If we are riding a horse, we can't move at all. And now let's go ahead and tell our horse to have a riding horse method here. So if I come over here, we can come in here and we can say func ride horse, let's say, and we can say riding is equal to true. And I know we don't have a function called riding, but don't worry, I'll get to that point. And then we can return our $ seating position dot global translation, just like that. And then I can do the same thing if I want to get off my horse. So func get off horse. And I can say riding is equal to false. And I can pass back my $ standing position dot global translation. And if I come up here and I add in a Boolean called riding, and I'll make that a type Boolean, that will allow me to determine if I'm riding, if my horse is being ridden, okay? And we'll get to this section here for the player side in a moment. But if we come up here, let me minimize this real quick. If we come up here, we can basically just say if riding, then we can go ahead and grab our player movement code here and basically just use that. So we'll just paste that, and we can set our speed up to something crazy. Since we don't have a speed thing declared, let's just say his speed is, I don't know, 20 for right now, and we can figure that out from there. And then we'll need to also else this and then tab all of this in. So if you're riding your horse, it will process movement code, and if not, then it'll process navigation code. And that's kind of a good way to approach doing a horse system, or doing some kind of system that's supposed to follow you but allow you to mount it. Now, what we can do is we can go back to our player. Now that we have this ride horse and get off of horse, we can go to our player and tell our player to ride that horse. So we'll need to say up here, var translation is equal to our result dot collider dot ride horse, just like that. And then we need to take ourselves off of our parent. So we'll say get parent dot remove child self. And then we need to take our horse. So result dot collider dot add, and we need to add ourselves as a child. So add underscore child self. And then we need to set our translation equal to the translation that we returned. And what that means is that we're returning the translation of our saddle position. So we'll come in here and just say global translation, whoops, not translate. Translation is equal to translation, just like that. And now, hopefully, if everything's done correctly, we can come up here, hit the space bar, and it didn't do what I wanted it to do, so that's always good. So let's see. All right, so I figured it out. So I guess we have to change this to 0,0,5. For some reason, it's raycasting in the wrong direction. And also, the result.collider needs to be an actual collider, not a misspelled, missing the I collider, because I'm very good at spelling. So now if we come over here, we hit the space bar, providing that we've got things set up correctly. There we go. We can now ride our horse. Nice. So now how do we get off of our horse? Because we're stuck on our horse. So what we can do is we can say, hey, when we hit our space bar, if we are riding our horse, just go ahead and jump off of it. If not, then raycast to get to our horse, right? So we can say if riding horse, then we need to fall off of it, right? We need to jump off of it. But we need a reference to our horse. So what we'll do is we'll get a reference up here and set it up here. So we'll just say var horse object, and we'll come down here and we'll just say horse object is equal to result.collider. And then we could probably clean this up a little bit if we wanted to. We could probably just pass in our horse object here, and we could probably pass it in here as well. And that just helps clean that up a tiny bit. And then we can just say horse object dot, and I believe we called it get off horse, just like that. And we'll go back to our player right here, and we'll say get off horse. And it's going to pass back a vector 3 of where we're going to put our player. So we will say var, and I believe we called it down here translation. So translation is equal to horse.get off of horse. And then we basically just have to do this exact thing, but the opposite, right? First, we have to do a get parent dot remove child self, and then we need to add a child to our root object. So we'll say get tree dot get root dot add child self, and then we will pass in our global translation equal to our translation, just like that. Now, this isn't going to work, and I'll show you guys why. If we run this and we run over to our horse just like this, and we get on top of them, and then we hit spacebar, you'll see suddenly we get an invalid index root on base null. But why is that? And the reason why is because you can't get tree from an object that is not in the Godot tree stack. Okay? So what that means is because we're removing a child right here and removing ourself from the child, and it's us doing it, we can't just say, hey, root, re-add us without getting a reference to our root first. So first we have to come up here and say var root is equal to get tree root like that, and then we can pass in our root dot add child. And now that should work. So if we come up here and we hit the space bar, we can run around on our horse, and then we can hit space, and we are off of our horse. And it's that simple. But you'll also notice that I can't move. I actually can't go anywhere right now. And the reason why is because of two reasons. One, our collider is currently disabled, and we are not setting our riding horse equal to false. So we'll say riding horse is equal to false, and then we'll also set our collision shape at the end, disabled is equal to false. And that will allow us to have our horse and be able to ride it and be able to get off of it. Just like that. And you'll see he's following us like you would expect. And that's basically how you can make a small little companion guy that you can have follow you around that you can climb on top of. All right. So that is all I have for you guys. So we talked about 3D. We went through all the 3D options. We talked about all of that. We talked about object collision and object avoidance. We talked about how to create a small object that follows around your player. And we created a small horse object that we could follow us around at different speeds. And finally, we made it so we could actually ride our horse because I figured it would be fun to actually do. So if you like this video, go ahead and hit that like button. And hey, if you dislike this video, go ahead and hit that dislike button because I am here to make content for you guys. This video was a viewer suggested video. So if you have any suggestions, please leave them in the comments below or hit me up on Discord and I'll be more than happy to put it on my Trello board, which I have a link to in the description below. And that's where I put all of my tutorials that are upcoming and things like that, providing that I keep it up to date. And hey, if you have any questions or comments, please leave them in the comments below or hit me up on Discord, links in the description below, and I'll be more than happy to help you out with any issue you might be having. But that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.